Hello and welcome. Hello and welcome to week 1 of regular human geography. The instructor for this class will be Mr. Bidwell, who is narrating this video. To start each week, we start with a content objective. As you can see below, the objective is guiding the lesson for this particular day, and you should be able to explain how geographers describe where and why by using maps. More specifically, you should be able to answer the I can statements, which will be at the end of the video. And those questions are one, explain how, where, and why questions are essential for basic human geography. 2, explain at least 3 maps that are used for answering the where and why. 3, discuss how projections and scales cause distortion in maps. And lastly, list at least 3 basic tools of a human geographer. When we look at maps and geography, the 2 basic questions human geographers use are why and where. So where is often the physical location, usually taking coordinates, lines of longitude and latitude, and the why digs more deep into explaining exactly what is it about that place that makes it unique, or what is it about, or why is it a region that has distinct features. Again, the why is descriptive characteristics of a particular place. Divisions of geography, we look at the physical pieces of geography, so those would be mountains, climate, volcanoes, rivers, anything that would make up our spheres in the world, the lithosphere, the crust of our earth, the biosphere, the makeup of plants and animals and vegetation, and then your hydrosphere, the water, rivers, lakes, oceans, and then you have your atmosphere, that would be in the climates and other various elements inside our Milky Way. A map is the most important tool of a geographer. They're used for referencing. They're used for choropleth maps, which is a gradient scale that depicts a certain data subject or data unit. There are dot maps that are used with frequency and density. There are symbol maps. There are cartogram maps looking at population. Topographical maps, those are going to be maps that look at the biosphere. A reference map here is common in political maps, as you see here, of the United States. It gives us political locations of capital cities. It has boundaries, which are formal, which we'll talk about later. So the boundaries are delineated by lines, as you can see with each of the lower 48, and then in inset pictures to the lower left, Alaska, and then an inset picture down below is Hawaii. Choropleth map, again, is taking a look at a data and then providing a look at the distribution of that data, usually with a gradient scale of 0 to 100 or any unit that's found in the key, as you can see below here with turkey production by state. In this particular choropleth map, the darker the color, the higher density or frequency of turkey production. Then as you move lower down the scale to the lighter colors, it shows less density or less frequency of turkey production. Again, a choropleth map looks at the distribution and gradient scale of a particular data subject. A dot map is going to be used for specific locations of a unit of measurement, such as this map shows milking cows. In the inventory of cows found, where we see those dots, we see a higher frequency of cow or milking of cows. Symbol maps is a look at a specific set of symbols, and the larger, in this case, the larger the symbol shows the larger number of that symbol, and the smaller the symbol, then it shows the less amount of that particular symbol unit. Cartogram maps are solely maps of population. The population is the size of a country, so it looks different than our previous maps we just saw in a cartogram. Again, shows that if a state is larger in size, it shows that it has a larger population than smaller states. So we can look at this map and determine that the two largest states or countries in the world are both India and China based on the large size. Topographic maps, again, take a look at natural landscape. So those, again, can be rivers or mountains or escarpments, in other words, cliffs. Again, it's to explain the where and why of topographical areas. All right, think about this question. Geographical vocabulary. You'll need to know place, region, scale, space, and connections. Cartography is the science of map making. A cartographer is a map maker. Make sure you distinguish between cartography and cartographer. Maps are scale models of the real world. The purpose of maps, there are really two purposes. One is a reference tool, explaining that where. It usually is coordinates of lines of longitude and latitude. And then also a communication tool, that's the why, explaining about those particular locations, places, or regions. Here we see a map of the Western Twin Cities, and it is used as a reference point. How do we know? Because it shows coordinates of various places such as Minnetonka or Wayzata, and it also shows coordinates of major interstates such as 494 and 394. Communication tool, again, when we look at these locations or regions, it gives us a more in-depth description of those regions or locations or places. And when we look at race and ethnicity in the Twin Cities in the turn of the 21st century, we can see that there's a distribution based on the colors of the pie chart here. That tells us the why about the place or locations or regions. All right, some of the first maps in the world. Here we see the first world map. And this first world map was depicted in 1569. A map scale is the relationship of size on a map to the size of that place or location on Earth. When we have different scales of map, it can definitely affect the detail and area covered. It can be expressed in three ways. We have ratios. So it shows that in this case, if you had a map and it said 1 to 15,000, that means when you look, and again, it doesn't show us the units here, but we want to make sure we pay attention to the units. 1, let's say, inch on a map represents 15,000 inches. And then you have a written scale, and it will write out exactly what an inch equals, or a foot, or a meter. Again, it's important to pay attention to the unit. And then you have your graphic scale, which is depicted right here. And then you have your large scale and small scale. Large scale, just think of it as a camera zooming in. You're going to have greater detail, but you're going to have a smaller area you're looking at. So again, large scale, you zoom in. And then the opposite is of a small scale. You zoom out. When you zoom out, you see less detail, but a greater area. Here we have a look at each of the scales. Here's a fraction scale, and then you also have a written scale, and then it shows where it fits in within these scales to a small scale map or a large scale map. All maps are going to be somewhere on this continuum of large scale or small scale. And again, think of Small scale zooming out, large scale zooming in. As you can see with the arrows, as it gets larger, there is more detail. Projections. Projections is taking a map off a globe, and that's referred to that transferring process. It's the most accurate depiction of the Earth is a globe. And when we look at maps, they can be distorted in the shape, the distance, the size, and direction. Those are the four common distortions. All maps are distorted. Some are least distorted than others. And then when we look at projections, they're either cylindrical or planar, conic, which is the form of a cone, or oval, stripped as in an oval shape. Here it shows you what we're looking at with cylindrical, common of Mercator maps. Mercator maps, if we go back to that first map of the world back in 1569, they used Mercator maps, and that was the first projection type of the New World. And what happened when they used a Mercator map, it was commonly used by maritime sailors, and so the middle latitudes were very accurate, but to the poles it was greatly distorted. Hence a common distortion of a cylindrical map. And then you have a conical perspective, and the conical perspective came later, and that was to try to eliminate the problems of distortion near the poles. So a conic is common of when we look at the Arctic and the North Pole, and then the Antarctic and the South Pole. They'll depict the greatest accuracy in that area where the cone is focused on that small area of Earth. And then you have your planar, and a planar is just taking any plane, hence planar, from the Earth, and wherever it takes that plane, it will have the most accuracy of that particular region or place on Earth. All right, so when we look at the distortion of Mercator, it can also distort the size of a country, especially if it's in the middle of a map. We can see the distortion of Mercator map when we get near the poles is greatly distorted, as you can see with the southern hemisphere and the northern hemisphere. All right, geographer tools of today. Everyone's heard of a GPS, the global positioning satellite. It's found in all cell phones. It has 24 military satellites that orbit the Earth, and they can pinpoint an exact location down to the second on Earth. Remote sensing is when you have, usually they're balloons in the air. They could be hot air balloons, and they send down satellite mapping to take pictures of various locations. Oftentimes remote sensing takes pictures of isolated and desolate areas of Earth that's commonly not found by way of human transportation. GIS is a storing system, so you have various GIS systems that will store, retrieve, and you can access the data, and the data is used to create mashup maps, which are layers of maps. Google Earth uses GIS systems. Mashup maps, going back real quick, are maybe if you're looking at, if you go into Google Earth, you can toggle. Maybe you want to look at volcanoes, and you want to look at cancer rates, and you want to look at children that are under the age of 5. You could take all of those 3 variables and mash them up to see if there's any correlation in particular locations or regions. This is how the tool of GIS is used. All right, and there it shows you kind of how the process happens at GPS with the orbiting satellites and with your cell phone. And there shows remote sensing. In this case, we have there's a balloon in the right, but then there's airplane. Oftentimes, again, they'll depict areas that are desolate from high altitudes. GIS here shows a mashup map, and then here shows another mashup map layering geographical data so you can find some connections and associations. And that will conclude Unit 1, Content Objective number 1.